Welcome to this lesson, Measurement Units and the Drawing Scale. The metric measurement system. In the daily life, we might need to measure the height of a person, the area of the living room, and the volume of a storage. In the metric measurement system, the main unit for measuring length or height is the meter. We use the meter to measure the dimensions of a room, like the length and the width of the room, not the area, and the height of a person and the short road distances. However, there might be times where it could be more convenient to use larger or smaller units. For example, we use the kilometer, which is 1,000 meters, to measure the distance between two cities, whereas we use the centimeter, which is 1 part out of 100 parts of a meter, and the millimeter, which is 1 part out of 1,000 parts of a meter, to represent the dimensions of a room on the drawing scale or on the paper that is used by architects. We can see here 7 units in the metric measurement system. Each unit is 10 times bigger than the unit that it comes before. For example, the centimeter is 10 times bigger than the millimeter. The meter, however, is 100 times bigger than the centimeter. So here, in order to move from meter to centimeter, we have first to move from meter to decimeter, multiplying by 10, and then another time from decimeter to centimeter, multiplying by 10. So in order to move from meter to centimeter, it means that we have to multiply by 100 or by 10 to the power of 2. If we want to move the other direction, for example, to convert from meter to kilometer, we have to divide by 1,000. Why? Because 1 kilometer equals 1,000 meters. However, the main units that we usually deal with, and you can see them present on the academic papers, are millimeter, centimeter, meter, and kilometer. So in the metric measurement system, the main unit, as we have just seen, for measuring height or length is the meter. It can measure the distances. However, the main unit for measuring area is the square meter, and the main unit for measuring volume in the metric measurement system is cubic meters. So here in this chart, we have chosen the main 4 units for measuring height in the metric measurement system, which are the kilometer, the meter, the centimeter, and the millimeter. So here it shows that, for example, if we want to move from kilometer to meters, we multiply by 1,000, and from meter to centimeter, we multiply by 100, and so on. Now, let's talk about converting area units. So let's consider this chart here. In this chart, we notice that, for example, if we want to move from squared kilometers into squared meters, we don't multiply by 1,000, such as the case when converting height units, but we multiply by 1,000 to the power of 2, or in other words, by millions. Why? Because let's assume we have here 1 squared kilometers. This is equal to 1 kilometer multiplied by 1 kilometer, which is equal to, here, if we want to convert 1 kilometer into meters, we get back to this chart for converting height units, and we find that we have to multiply by 1,000. So this 1 kilometer is equal to 1,000 meters. And again, this 1 kilometer is equal to 1,000 meter. So the result will be 1 million square meters, or 1,000 to the power of 2 square meters, which is the same as we see in this chart. 1 squared kilometers equals 1,000 to the power of 2 squared meters. And by looking at the chart for converting volume units, we can reach the same conclusion, but instead of multiplying by 1,000 to the power of 2, we have to multiply by 1,000 to the power of 3. Why? Because we have 1 kilometer multiplied by 1 kilometer multiplied by 1 kilometer in this case. Now we have those same charts present on this page, and we want to do some small tests for converting units. First of all, we have 10 squared meters, and we want to convert it to squared centimeters. So here, since we have squared meters, we have to go to the area chart here, and we have squared meters. We want to convert this into squared centimeters. For this reason, we need to multiply by 100 to the power of 2. So 10 square meters equal 10 multiplied by 100 to the power of 2 centimeters. And this equals 1,000, 100,000 square centimeters. Let's now move to the other example, 0.3 meters. In this case, we have to go to the chart that talks about converting height units. We have here meters, and we want to convert this into millimeters. For this case, we have to move 2 steps from left to right. It means we have to multiply first by 100 and then by 10. So 0.3 meters equals 0.3 multiplied by 100 multiplied by, by 10 equals 0. Of course, here now the unit is millimeters. 0.3 multiplied by 1,000 millimeters, which is equal to 300 millimeters. Now we move to the other example, 3 square meters. We want to convert it into squared kilometers. So we go to the converting area units chart. So we are here, square meters, and we want to move to squared kilometers. It means that we have to divide by 1,000,000 or by 1,000 to the power of 2. So 3 squared meters is equal to 3 over 1,000 to the power of 2 square kilometers. You can move further if you like the calculations, but the purpose of this test is just to show what is the right conversion and what is the right amount that we have to multiply or to divide by. In the last example, here we have half cubic meters. So it means we go to the chart of converting volume units. We are here and we want to convert this to cubic kilometers. It means that we have to divide by 1000 to the power of 3. So equals over 1000 to the power of 3 cubic kilometers, 1 over 2 multiplied by kilometers. The drawing scale. Sometimes we need to represent the actual things by drawings of reasonable dimensions so that we can deal with the problems related to them with comfort. For example, the drawing scale might be 1 over 100,000. This means that if we divided the actual distance into 100,000 equal parts, then the distance on paper would be equal to the length of one part of these 100,000 actual parts. The length on the drawing must be in proportion with the actual length. For example, if we have, let's say, a room in a house with the length of this room, and here is the width. The length equal 4 times the width. If we take the actual measurements. So now on paper, we must maintain this. So the length on paper also must be equal to 4 times the width on the paper. This means that we are maintaining the proportion. So let's take some real life examples. We have a piece of land with a rectangular shape. Its length is 100 meters and its width is 32 meters. Whereas its width on paper is 8 centimeters. Find its length on paper. As we have seen before, we have to maintain the proportion. In other words, the ratio of the actual width to the actual length must be in proportion with the ratio of the width on paper to the length on paper. So we have here the actual width is 32 and 32 meters, and the actual length is 100 meters. This must be in proportion with the length. The width on paper is 8 centimeters, and we have x is the value we are looking for, which is the length on paper. This will give us x equals 8 multiplied by 100 divided by 32. This will give me 25. Here we have it in centimeters on paper, so it is centimeters. A map shows that the drawing scale is 1 over 100,000. This means that if we divided the actual distance into 100,000 equal parts, then the distance on paper would be equal to the length of one part of those 100,000 equal parts. So let's see the first question. If a distance between two cities on the map is 7 centimeters, calculate the actual distance between these two cities. So the drawing scale in this case, which is 1 over 100,000, must be equal to 7 over x. This gives us 7 centimeters over x. This will give us x equals 700,000 centimeters. This is the distance, the actual distance. We convert into meters by dividing by 1,000. This or to meters by dividing by 100, sorry. This will give us 7,000 meters, which is, again, by dividing by 1,000, will give us 7 kilometers. Second question, if the actual distance between two towns is 30 kilometers, calculate the distance between these two towns on the same map. So here we consider the same drawing scale, 1 over 100,000. This is equal to x, which is the distance on the map, over 30 kilometers, which is the actual distance. And this gives us x equals 30 over 100,000, and this gives us 30 over 10,000. Of course, kilometers, 3 over kilometers, which is by multiplying by 1,000, 3 over 10 meters, which is again 30 centimeters, by multiplying this by 100. Thank you for watching.